Good day, grade 10. This is day 46, lesson 6 of Analytical Geometry, chapter 8. It's the 8th of June. And today we are going to talk about quadrilaterals because that's a way that they ask analytical geometry a lot. So they use the properties of quadrilaterals to ask analytical geometry. So we've learned a few formulas. We've learned the distance formula, the midpoint formula, and also the gradient. These we are going to use to prove that quadrilaterals are certain types of quadrilaterals. Like for instance, the first one is a parallelogram. To prove that a quadrilateral is a parallelogram, we have to prove that the diagonals bisect each other. So then the quadrilateral is a parallelogram. To determine on a Cartesian plane, we will show that the diagonals share the same midpoint. So if I work out the midpoint of the one diagonal and the midpoint of the other diagonal and they are the same, then they do bisect one another. So let's read the question. Quadrilateral TIME is drawn on the Cartesian plane. Prove that it is a parallelogram. Okay, so I'm going to work out the midpoints of each diagonal. So the first midpoint is the x values added divided by 2. And the y values added divided by 2. So I'm going to work out EI, the midpoint of EI. That is negative 2 plus 5 divided by 2 and negative 3 plus 5 divided by 2. And that's 3 over 2 and 1. So that is the first midpoint. Then the other diagonal, TM, x values added divided by 2, y values added divided by 2 to get the midpoint. So it's 3 plus 2 divided by 2, 3 plus 0 divided by 2 and 0 plus 2 divided by 2 gives me 3 over 2 and 1. So yes, P, 3 over 2, 1 is the midpoint of both diagonals. So that means that quadrilateral TIME is a parallelogram because its diagonals bisect one another. Okay, so let's remember that is how we're going to prove that something is a parallelogram. Okay, so let's remember from Euclidean geometry that there are other ways to determine if something is a parallelogram too. We can prove that both pairs of opposite sides are parallel, or both pairs of opposite sides are equal, or that one pair of opposite sides are parallel and equal. We could have used any of those. Let's look at some other quadrilaterals. The first one is a rhombus. To prove that a quadrilateral is a rhombus, let's quickly draw one just roughly. Oh goodness, that's no good. Okay. Roughly, a rhombus can be defined as a parallelogram in which the adjacent sides are equal, or as a parallelogram in which diagonals are perpendicular. So which means the diagonals have to be perpendicular to one another. Okay, so that's the method that we're going to use. We are going to show that they bisect and that they bisect at a 90-degree angle. Okay, so let's remember, in a parallelogram, we used the midpoint to determine that the diagonals have the same midpoint, so they bisect. And then I have to still prove for a rhombus something else gets added, and that is that they bisect perpendicularly. How can I show the two lines are perpendicular again? I can use the gradient. So it's going to be the one gradient multiplied the other gradient will give me negative 1. Then they are perpendicular to one another, the diagonals. Then a rectangle. Okay, so let's look at a rectangle. How are we going to prove that something is a rectangle? It can be defined as a parallelogram of which the diagonals are equal, or as a parallelogram with one interior angle equal to 90. The latter will be quicker. Okay, so first I have to prove that it's a parallelogram. How do we do that again? We prove that they have the same midpoint. The diagonals have the same midpoint. Then something extra that I have to prove for a rectangle is that one of the interior angles is 90 degrees. So that's how I'm going to do that. For a square, we have two methods. The first method is that a square is a rhombus with one interior angle 90 degrees. Okay, so a rhombus, what do we need for a rhombus again? We need to prove that the midpoints are the same and that the diagonals bisect one another perpendicularly, and then for the square something else gets added, and that's that one of the interior angles is 90 degrees. So I need three things to prove that it is a square. The second method is a square is a rectangle of which the adjacent sides are equal. So first we prove that it's a rectangle. How do we prove that something is a rectangle again? We prove that the diagonals bisect one another, and then we prove that one of the interior angles is 90 degrees, and then I have to prove that one pair of adjacent sides are equal. Adjacent are the ones that touch one another. Opposite sides are right across from one another. Okay, so adjacent sides are the ones that touch one another there. Okay, so that is the adjacent sides that are equal. Then a trapezium. If we can remember what a trapezium looks like, it's this one. The only way that I can prove something is a trapezium is by proving that the opposite sides are parallel. And then a kite. For a kite, don't have a lot of space to draw a kite right now. Okay, so there's a kite. We simply prove that two pairs of adjacent sides are equal, or we prove that one diagonal is bisected by the other at 90 degrees. Okay, so I have the two diagonals. Then these two will be equal, and those two little lines will be equal. They bisect. The short one gets bisected, and it is at 90 degrees. Or another way is to prove that the adjacent sides are equal. Okay, so that's how we're going to prove quadrilaterals. Now, you do exercise 4 on page 202 or in your notes, and then you come back, you press pause, you do that, and then you come back and we mark it together. Welcome back to exercise. Oh, so here's the exercise, and then I'll be right back with a memo. Welcome back to exercise 4 on page 202. Okay, let's read number A. Quadrilateral DEFG is formed by points D. Okay, so now I'm going to draw a little picture for myself. Okay, I'm going to draw a quadrilateral. It's not even on a Cartesian plane. I'm just drawing it to get a picture in my mind. D, -5, 3. E, 3, 5. F, 2, 1. And G, -6, -1. Show that DEFG is a parallelogram. Okay, so how do we prove that something is a parallelogram again? I just proved that the diagonals have the same midpoint. So I'm going to work out the midpoint of each of the diagonals. First, diagonal DF. The midpoint of diagonal DF is 2x plus -5 divided by 2, and 1 plus 3 divided by 2 gives me -3 over 2 and 2. Then the midpoint of EG, the other diagonal, is -6 plus 3 divided by 2, and -1 plus 5 divided by 2 gives me -3 over 2 and 2. So that means that the midpoints are equal. So I can write it like this. The midpoint of DF is equal to the midpoint of EG. So that means that DEFG is a parallelogram because the diagonals bisect. Alright, number C. Number C says, given A, 0, -3. Let's quickly just write down the coordinates. A, 0, -3. B, 4, 0. C, -2, 8. And D, -6, 5. We have to show that ABCD is a rectangle. So let's quickly just draw a rectangle. Okay, and always the letters are in order, A, B, C, D, like I would draw the rectangle with my finger. So, now, to prove that something is a rectangle, I first have to prove that the diagonals bisect, so I have to prove that they have the same midpoint. And then I have to prove that they have a 90-degree interior angle. So for that I'm going to use gradients. Okay, so let's start by proving that the diagonals bisect. I use the midpoint formula. I say the midpoint of AC. So the first diagonal is the x values added divided by 2 and the y values added divided by 2. That gives me 0 plus negative 2 over 2 and negative 3 plus 8 over 2 gives me negative 1 and 5 over 2. Then the midpoint of BD. X values added divided by 2, y values added divided by 2. 4 plus negative 6 divided by 2 and 0 plus 5 divided by 2 gives me negative 1 and 5 over 2. So that means that this negative 1 and 5 over 2 is the midpoint of both diagonals, so the diagonals bisect. So I have the first point checked, that the diagonals bisect. Okay, so at the beginning I wrote, this is what I'm going to do. I have to get that they bisect. That's checked. Now I have to prove that one angle is 90 degrees. I could have used any of the sides, but I used AB and BC. I used AB and BC to show that they are perpendicular. So I'm going to work out the gradients. To work out the gradients, it's delta y over delta x. Y values subtracted over x values subtracted. So it's 0 minus negative 3 over 4 minus 0 gives me 3 over 4. Then BC's, the gradient of BC is the y value subtracted over the x value subtracted. 8 minus 0 over negative 2 minus 4 gives me negative 4 over 3. Now I multiply the gradients. I multiply them. 3 over 4 times negative 4 over 3 gives me negative 1. Yes, that is what I want. So AB is perpendicular to BC because the answer is negative 1. So one interior angle is 90 degrees, which means I've got this second point checked. Now I'm going to make a conclusion. ABCD is a rectangle because the diagonals bisect and one angle is 90 degrees. Guys, these words are very important. Sometimes it just looks like it's something extra, but it's actually very important. It's part of the question, it's part of the answer. You need to write it down because it counts for marks. Now number F. In the following sketch, ABCD is a parallelogram. So I copied the sketch here. Let's look at it. The diagonals AC and BD intersect in P. Okay, so the diagonals intersect and they give me the coordinates of P is negative 1, 5 and 3. D is a point on the x-axis. Okay, D is a point on the x-axis. The gradient of BD is 6. Okay, so we have the line BD and the gradient of that one is 6. Determine the coordinates of C and D. Okay, so here's our plan. First, to determine the coordinates of C, I'm going to use this diagonal AC and I'm going to say I know that P is the midpoint of AC. So I'm going to use the midpoint formula to determine the coordinates of C. Let's say that C has coordinates x, y. So I'm going to determine x and y by using the midpoint formula. C is x and y, so P is the midpoint between C and A. So it's going to be the x values added divided by 2, the y values added divided by 2. Then I set the x values equal to one another and the y values equal to one another. X values equal to one another is negative 1, 5 is equal to x plus 3 over 2. Y values equal to one another is 3 is equal to y plus 2 over 2. So now I'm going to work out x. I multiply the 2 on the other side, so I get negative 3 is equal to x plus 3. Subtract the 3 on the other side and I get x is negative 6. Now to work out the y value, I do the same. Multiply by 2 on the other side. I get 6 is equal to y plus 2. Subtract the y from the 6 to get y is equal to 4. So C is the point negative 6, 4. I can write that in negative 6, 4. The x value negative 6, y value 4. Now to get the coordinates of D, they tell me that it's on the x-axis. So one thing that I know is that the y value will be 0, because on the x-axis the y value is always 0. The x value of D I do not know, so let's just call it xd. So they gave me some information about this diagonal BD. They said that the gradient of BD is 6, which means the gradient of PD will also be 6. So the gradient of PD is 6. Okay, so now I'm going to say YD minus YP. So I'm going to work out the gradient with the difference of y over the difference of x. It's YD minus YP over XD minus XP. That must give me 6. So let's take the y values. 0 minus 3 over the x values. XD minus negative 1,5. And that must give me 6. So that is negative 3 and xd plus 1,5 is equal to 6. This xd plus 1,5 I multiply on the other side in brackets. So I multiply it in and I get 6xd plus 9. So then I subtract the 9 on the other side. I get 6xd is equal to negative 12. Divide by 6 and xd will be negative 2. So the coordinates of D will be negative 2 and 0. Alright, then the last question, number F2. Use analytical techniques to determine whether or not ABCD is a rhombus. Okay, so determine if it's a rhombus. To determine if it's a rhombus, I'm going to check if the diagonals are perpendicular. Okay, so is DP, which I just know, the gradient is 6. Is that perpendicular to AP or AC? You could have used AC or AP. Alright, so I'm going to use AP. Okay, the gradient of AP is delta y over delta x, which is 3 minus 2 over negative 1,5 minus 3 gives me negative 2 over 9. The gradient of DP is 6. I didn't even need to do all this in between because they gave it to me as 6. But I could have worked it out if I wanted to. Okay, so the gradient of that is 6. Now I multiply the gradients with one another. I want the answer of negative 1. If the answer is negative 1, then they are perpendicular. Okay, so I multiply them and I get the answer is negative 4 over 3, which is not equal to negative 1. So that means that AP is not perpendicular to DP, so ABCD is not a rhombus. Alright, and that's it for today. If you have any questions, email your teacher.